Hello, and welcome to Davis R Users Group. I see a few new faces. The goal of Davis R Users Group is to help support researchers use R on campus. So we do that in a few different ways. One of them is just getting people physically co-located every now and again, and that's what we use this space for. Another one is teaching tutorials, which is one we're going to go over today, is using dplyr to summarize your data. And then another one is through presenting other people's research. So sometimes we have people come in and either talk about their work or something that they've done in R or whatever, just to expose people to different problems that other people have had or how they have solved those problems. So thank you for coming. Today we are going to talk about dplyr. We started this lesson on November 7th of 2019, and we're finishing it today. So I'm going to start with a brief summary of what we went over a couple months ago, 2 months ago, and then we will go through the functions group by, summarize, arrange, and count, which all live in dplyr. Is this big enough for everybody to see? Okay, great. So the other sort of point of business is this code that I am working on here, if I go to the right document, is available at that link. And every time I save my script, it will refresh and you will have everything that I have. So if you don't want to type this URL, or if you get lost, you can copy and paste the code from that link into your R session and you will have what I have. So to start out, you can type this URL out if you want to download our data that we're going to be working with. The data set is the portal data. It's been used in over 400 studies, ecology studies. It's count data from animals in different plots, and sometimes their weights and heights and other morphometric measurements like that. And we're going to be summarizing it. So you can either grab that, the code from that URL and copy and paste it in, or you can type it out yourself. If we run this, we see that in our console, we see trying URL and then downloaded 2.9 megabytes. And then since I saved mine, this dest file argument puts it into the data folder. I have a data folder that I created, and I see that I have this portal data joined.csv in that location.
So this is my first time here, so sorry if I slow things down.
No, you're good.
But I didn't follow what you said about the dest file. Where's that?
Okay, right. So the URL specifies where the file lives on the internet. So that's where we're pulling it from. The dest file, this argument is what we use to say where we want it to save on our computer. So sometimes when you click download, you get like a dialog box that pops up and you can click through and pick a folder and name the file. That's what we're doing here. So if you don't have a data, in my current working directory, if I type git wd in my console for git working directory, I see that the folder I'm in on my computer is users, tr, dropbox, teaching _r. Within that folder, if I go to my files pane, so I see it's home, dropbox, teaching R, I have a data folder. So I can save it as whatever file name I want. I chose portal data joined in this folder. If you don't have this folder in your current working directory, you can delete this and delete that. So you're getting rid of that data folder, and then you can download into it. I'm gonna leave them there because they're there. You can also create a new folder by clicking this icon here, and then typing the name of the folder that you want if you want to generate that folder from R Studio. Okay, another thing, if you haven't come to our users group before, we're going to be using this packages in the tidyverse. So I have tidyverse installed, and I installed it by running this command. You might need to run it yourself by removing this hashtag. Putting the hashtag in front of it makes it a comment. If I remove it, then I can run this. I'm not going to run it because I already have this installed, but tidyverse is an umbrella package that when you download it, it installs packages like dplyr, which we're using today to summarize and mutate our data. Reiter, which is a way to read in like CSV files and that sort of thing. It's what we use here, read_CSV. is from the Reiter package, ggplot, if you've seen those types of plots before, and about 16 other packages that I won't go over. But this allows us to download them all at once, and then library tidyverse loads them all into our current working environment so we can start working with them. So if I run this, on my computer, I have a Mac, so if I press Command Enter, it runs. I can also press the run button up here and it would run, and I think if you're on a Windows, it's Control Enter, and then it'll run. Michael, do you have a Windows? Okay, I didn't think so, but okay, I would have picked on you for the rest of the time if you did, to get those sorts of tricks from you. All right, so can you put your green stickies up when you have run read_csv with the name of the file wherever you have it saved, and you have this object down here or wherever your global environment is that's surveys? Can you put your green sticky on top of your computer? We'll use those to signal that you're still working or that something has worked or whatever. And then I'm also going to solicit some feedback at the end using those too. And I'm going to come around and just take a peek at getting everybody caught up. Perfect. Yeah, but go ahead and remove that, and click save. That's okay. It's telling you this is a CSV, which is different than an Excel document. Yep, that's what we want. And then come to, do you have R in RStudio? Okay, so go ahead and click on that. Perfect. No, you're good. This is the point. We are here for you. Okay, so what just happened is it tried to run this script when you opened up your RStudio. We'll fix that afterwards so it doesn't do that anymore. So go ahead and say, do you want to close this file now? Yes, you can close it. And then, yes, you can close that one as well. So now we'll start a blank script. So do file, new file, R script. And then now you're ready to start writing stuff down. So if you go to that URL, you can copy and paste a lot of the code that I have already, and then you'll be good to start. Yep. So I'll let you go ahead and get started on that, and then go over to get your computer.
I think I'm there.
Yep, you are. You're good.
And so then you suggest that as I go along, that I'm going back and forth with this, just like copy and paste it all right in right now.
You can copy and paste it all right in right now if you want. We're going to review these with these, and then the rest of the stuff that I do, I'm going to live code. So type it as we go. So you can follow along with typing. Okay, yeah. These things, since we covered them before, I didn't want to just be like, okay, now remember mutate that we haven't done in 2 months, so that you know, in case people think that weren't at that lesson. So I just have a little cheat sheet there.
Okay. So if I copy and paste this in, but then the rest
we'll type in. Yeah. Perfect. So, okay, come here and click Files. I'm going to see where you're at. Okay, so do these things look familiar to you? Okay. Up a level. That's going to be hard. Can we create a new folder from inside of here, and then you work inside of that? This is in your documents, isn't it?
No, it's not. But I can do it within R.
Yep, so go ahead and click new folder. And maybe call it like data star users group or something like that. Perfect. Yeah. And then click on that. And then inside of here, come over actually to the top of the script, and we're going to run one thing that's not in here. So we're going to change your working directory. So if you put your cursor on line 13, and then type set WD with lowercase s. empty. And then an open parenthesis. And I think it will still work with that space, but usually you don't want to put a space there. But and then in quotes, type the name of that folder. And press tab. It'll finish it for you. Press tab. There you go. Press tab one more time. Perfect. And then that changes your working directory, so you're inside of here for the rest of this session. So go ahead and run that. Run. And then we're going to create one more folder. So click new folder. And type data. Do it with a lowercase actually too, because that's ours. Okay. And now you can run lines 22. If there's anywhere on there, and click run and over. And then remove the hashtag from line 25.
Give me that.
Yep. And go ahead and run that. Okay, so this is going to install everything that you need. And now
Why is all red?
it's telling you that it's installing them. So it's giving you messages and it wants you to be aware that that's happening. So put it in red. Okay, so we have everybody with, you'll have Tidyverse soon. And once it's done streaming red across your screen, you can run line, I think it's 27 for you, it might be 26, but library Tidyverse, and then we will all be caught up. Okay, so, right, we downloaded some data. If you didn't already have Tidyverse, we installed it, and then we loaded it. So loading this in gives us access to all of the functionality in all of the packages that are inside of Tidyverse. The ones we're going to be working with today are primarily dplyr, and then this command right here is also Reiter. So that's why we're loading all of Tidyverse, because we're using multiple packages from that library. Did it finish installing for you? Okay, so go ahead and run this line of code here, library Tidyverse. And then you can run surveys read _ CSV, and we'll see some red again. Red does not always mean bad. So sometimes red, especially when you're working with Tidyverse packages, is just the package telling you to be aware that something happened. So in our case, it says parse with column specification. Columns are record ID, month, day, year, plot ID, species ID, sex, time code, weight, and it tells us what type of data are contained in here. So double is numbers, and then these are characters and then numbers again. So this is telling us that it read our document, and each of these are different columns in our document. We can look at this a different way as well using the str or structure function. And it tells us some pretty similar information, but it gives us a little bit more as well. So it gives us a preview of the first 6 or so observations of each of our data, of each of the columns in our data frame. Alternatively, if we want to get a view of this that's a little bit more like a spreadsheet, we can run the view command, which is this one here with a capital V. It's one of the few commands that start with a capital in R, and then we get a spreadsheet-like view. So this is our data frame of the data that we just read in. Okay, so this is what we're going to be working on summarizing. So we can also see down here in our global environment, your global environment might be up here, but we have 34,786 observations of 13 variables. So 34,000 rows and 13 columns. So we're going to be using dplyr to summarize this information. There's a few things or questions about that so far.
I can't use the view to get the spreadsheet.
Okay, Ryan will help you. Okay, so in November when we did the dplyr lesson, we went over a few functions, namely 4. So the first one is select. So I have 2 examples typed out here. But what happens when we use select is we give it the function name, select. It's an open parenthesis. That's how we know it's a function in R. These parentheses designates that it's a function and something's happening. The arguments are the data frame that we're going to be working on. And then we give it the column names that we want to keep. So in this example, if we run this, it runs and then we get a data frame back, and it only has 3 columns now: plot ID, species ID, and weight. So the select function selects the columns, and it knows which columns to keep because we typed out the column names here. So the 3 column names we provided all ended up in the data frame that came out. And we see that we still have 34,000 rows over here because none of the rows were dropped by select. We get everything back. Conversely, you can use select to remove rows. So if we put a minus sign in front of this, the column names, we get rid of record ID and species ID from our data frame. So we see that those are no longer here in our data frame. Questions about the rapid review of select? Okay. Alternatively, or conversely, I guess, you can use filter, which instead of acting on the columns, acts on the rows. So if we use filter and we give it our data surveys, and then we say that we want to filter for any observation of year that is equal to 1995, when we run this, we see that instead of 34,000 rows, we now have 1,000, and we still have 13 columns. We got back every single column that we had before, but now year equals 1995. So that's the only thing that we got back. So we filtered down to the rows that contained year with 1995. Questions about filter? I promise the second half is going to go slower.
So the filter, when year equal to 95, everything else got dropped.
Correct. Any year that was not 1995 is dropped out.
Can you just say again what, because you said something about like it's gonna always say 34,013 variables as long as we didn't actually change the definition of it.
Correct. So we've been running these commands, and every time we run them, so watch my console on the left there, or right. So let's run it. Did you see it kind of stream past? Let's change this to 1996 instead. I don't even know if there is anything in 1996. Yeah, okay, so it's been printing to the console. We're not saving this result anywhere right now. We'd have to assign it to an object to keep it. So if we wanted to do that, we could do surveys 1996. And if I run this time, the only thing that printed to the console is our command. But now down here in my objects global environment area, I see I now have an object, a data frame called surveys 1996. And this one has 1,689 observations of 13 variables. But we didn't overwrite surveys, so that one has stayed the same. Okay, so you can use select and filter on their own, but sometimes you want to do multiple operations on the same data frame, so it's nice to string them together. So that's what this pipe allows us to do. So we take surveys and we're piping it into filter. So where we previously gave surveys as the first argument to filter, this pipe says, assume that surveys is the first argument here. Then whatever comes out of this command here, pipe it into select. And now select from this data frame that was already filtered, species ID, sex, and weight. So what this accomplishes is that you can both filter to anything that weighs less than 5 and select these 3 columns. But you're doing it all in one command instead of breaking it out into commands. And that's useful to combine your operations together, and it's like an organizational tool that you can use. It makes your code sometimes a lot neater and easier to follow what you're doing. So if we run this and I scroll up a little, we see that this one only has 17 observations because not very many things weigh less than 4 kilograms, but it still has 3 columns. Because we selected for species, sex, and weight, and those are the 3 that end up here. Questions about pipes?
For another time.
We can go over it after, yeah.
I've got an intro and yeah, I haven't grasped it yet, but keep going.
Sometimes I find when you just let the information wash over you multiple times,
It's not
little things cling.
Yep.
Other times they don't. Okay. Last one before we start going more in depth into how these things work, mutate. So we're taking surveys, we're piping it into mutate. So that's, in this case, it's the exact same thing as writing surveys. Sorry, that's not it. It's the exact same thing as writing mutate, giving it the data frame, surveys, and then saying that you want weight kilogram to equal weight divided by 1,000. So what mutate is doing is it's saying take the weight column that already exists in this data frame and divide every number in there by 1,000. Don't overwrite the weight column, keep that, but make a new column in this data frame called weight underscore kilogram, which keeps the product of this division. So if I run this and scroll up a little bit, we still have 34,786 variables, but now instead of 13 columns, we have 14. And we see right down here at the bottom, where it lists our extra column names that didn't make it onto our screen real estate, that weight kilogram is now included in that. So we could use our pipe and pipe our data into mutate like this, or we can set our function up like this, where we mutate, we give it the data frame surveys, and we make a new column called weight underscore kilogram.
So these two are the same result.
These two are the same result. Yes, exactly. But where this is a standalone function, we could put a pipe at the end of this and do another filter or do another select and do more operations on this data frame, just depending on what our goal was. Okay, the reason I did a crash course in these commands is because we're going to be using them in the second half, or in this lesson. So I wanted to make sure that everybody had at least seen them before we start introducing these other concepts. So what questions do you have about these before I move on to our functions of the day? Picasso, you can go to that URL, and all of the code that's in this file is available to you, and you can copy and paste it into RStudio and start running it. Okay, I am going to use an organizational technique in RStudio. If I press on my computer Control-Shift-R all at the same time, I can create a header in my code. So I'm going to call this split, apply, combine. So I got this to pop up by pressing Control, Shift, and R all at the same time. It also works with Command, Shift, and R. And what's nice about this is it gives me a new section that I can use to organize my code with. So if we come up to the top here, I have a review of dplyr commands. Because it's a section formatted like this, I can collapse it. And now I don't have to look at it, and I'm just on the split, apply, and combine section. Or I can uncollapse it. You don't have to do that if you don't want to. Okay, so raise your hand if you've ever heard of split, apply, combine before. I really hate this term, even though it does do a good job sort of describing exactly what it's doing. It just does not make any intuitive sense to me, and it took me a really long time to understand what it was doing. So many data analysis tasks, you have to split your data into groups of some sort, apply the same statistical test or summary on all of those groups, and then you want to get all of those groups back, the results of that, so that you can look at them all at once. So we can think of this let's say that in our portal data, you need to separate by males and females to get the mean weight, because sex impacts weight, and so we want to separate those out to see, looking at species dimorphism or something like that. We would have to split our data into all the males and all the females, take the mean of the weight, but you don't want those means to be floating around by themselves. You want to put them back in the same object so that you can look at them together. So that's what this split, apply, combine technique does. And there's a lot of ways to accomplish it, but the easiest to read in R is usually dplyr. So the way that we do this is with a function called group by. So I can use our surveys data frame, and I'm going to pipe it to the command, to the function group by. and I'm going to group by sex. So this accomplishes the first part of our split, apply, combine. I'm splitting our data set by sex. And then I can pipe this to summarize. And in this case, I want to summarize by weight. So I'm going to make a new column called mean weight. And to calculate what this is, I'm going to use the function mean, give it the column weight, but I want to remove the NAs from this. I'm also going to say NA RM equals true. We can go over that NA part in a second, but let's run this. So when I run this, I get back a data frame. It has 2 columns and 3 rows. In it, I have sex, there's female and male, and then NA. The mean was calculated on all of the females, and it's 42.4. For the males, it's 43. And then for anything that didn't have the sex reported, it's 64.7. So what happens here is that I'm splitting by sex. That's the first thing that I do. And then I'm calculating the mean weight. But I have to remove these NAs because there's a chance that in this, there's some females that were reported as female that don't have a weight. And if I don't remove the NAs, you can't calculate the mean. So that's why I have to give this argument to the mean function. Questions about this? So the first line does our split, where we're splitting by sex. And then the second applies this command where we're finding the mean. And then under the hood, a dplyr combines these together and gives them back to you as one data frame. So you don't have to worry about collecting the results.
Question?
Yes.
When you say split, are you really grouping 2 sets differently?
I really am.
Is that what you call it splitting?
Mm-hmm. Yeah. So the split technique, how you do that is using this group by command. So the thing that's kind of funny about group by, let's try and run this. So we'll do surveys and pipe it to group underscore by. And we're going to group by sex again. But we're not going to pair this with anything. We're not going to pipe it to anything. I'm going to run this. And what I get back is a data frame with 34,786 rows and 13 columns. So it basically gives us back the data frame without doing anything to it. The reason why is because this group by is something that just happens internally. It doesn't produce anything that's different for you to see, but it produces something that's different for summarize to see. So if you don't pair group by with anything, you don't get 2 data frames back. Because in this, you never want to split your data set up into 2 totally separate data frames. So what's happening underneath the hood is that they're separate from each other so that you can apply this summarize to it, but they're not actually completely separating into 2 different objects that populate your global environment. Does that make sense? Yeah. So this group by is saying in this data frame, all the males and females belong together. And it tells summarize that, or it tells whatever is happening after the group by that. But it's not a way to get 2 separate data frames back with males and females. So that was great. But we can also group on more terms. So instead of just sex, we want to split this out by, let's say, species ID. So we could do surveys. I am always horrible at typing surveys. Okay, surveys, and we pipe it to group by. And we give it sex, and then also species ID. And then we can do the same operation where we summarize. We're going to make a mean weight column again in our final object. And we're going to call it, or sorry, we're going to calculate it using mean on the weight, and na.rm is equal to true. So we're going to remove the na so that we can calculate the mean. So if we run this time, this is a lot bigger. It's 92 rows. It only prints out the first 10, so it's a little bit easier for us to read. We see that sex and all of these are female because we can't see the male rows because they're down at the bottom. The species ID is recorded here. If you were an ecologist and this was your study, I'm sure you know what each of these species are. And we can see that the weight, the mean weight, varies a lot by species. So where for one species it's 9.16, for another it's 154. So in this case, you might want to separate to do the split apply combine on multiple columns because you get a more granular view of what's happening in your data. Question? Oh, yes. No? Okay. What I get? It's a little different.
So you got 3 columns. Where's the species?
Sex, species ID, and mean weight, because I grouped by sex and species ID. So this group by will bring in both of these 2 columns that I grouped by. Okay, so these NAs that we've been getting, even though we can use this na.rm equals true so that they're not calculated in the mean, they're kind of pesky, so we might want to just get rid of them from this calculation altogether. So we can continue building this dplyr command to have more rows in it. So we could do surveys. We can pipe that to filter. And when we filter, we're going to give it an exclamation point and then is.na. So what this is it is a function called is.na. And it'll tell whether there's an na in weight. And then the exclamation point is negation. So what this allows you to do is filter anything in weight that is an na. So it'll remove any of the nas from weight for you. So they're all gone. So if we run this on its own, we can see that there are 32,283 observations instead of the almost 35,000. So we've gotten rid of just over 2,000 by filtering anything in weight that was an NA. Yes.
What's the difference between this filter explanation is.na and weight than the previous sentence na.remove?
Yeah. So what this na remove is doing is when you calculate the mean, it's removing the NAs from the thing that you're calculating the mean from. So it's basically ignoring them. So it calculates the mean on anything that's not NA, but it leaves them in the data set. Versus here, we're saying get them out of the data set. We don't want to see them at all. So then, since we know that this filter works and gets rid of our NAs, we can pipe this to group by, and group by sex and species ID again. And then if we pipe this to summarize, we can do mean weight is equal to the mean of weight. And now since we've already removed all of our NAs, we don't need this na.rm argument anymore. This will work on its own. So if I run this, I now see that there's only 54 more rows because we've gotten rid of all of our NAs. So before there was, I think, 92, and now we have 64 rows. So they are no longer in our data set. We've just completely removed them. Questions about that so far? Okay, so summarize has a lot of flexibility. So where we've been doing mean weight, you can do lots of different things instead. So let's type out this, this filter and group by again. So we'll do surveys and we'll pipe it to filter. And we're going to remove our NAs. And then we'll pipe that to group by. We're going to group by sex and species ID again. Oops. And then we will pipe this to summarize. We still want mean weight. We haven't decided that we don't like that anymore. So we'll do mean underscore weight and mean of weight. But then I'm going to put a comma after this. And I can also do minimum weight. I forgot a T there. And here I'm going to use the min function, still applied over our weight column. And this will give me back two new columns. One that has the mean weight of things split by sex and species, and one that has the minimum weight of things split by sex and species. So if I run this, it sort of looks like we got the same result back where we have sex, species, and mean weight. But Tidyverse tries to save us, our little console, from overflowing with too much text. So we can see down here that there's an additional variable called min weight that was not printed to our screen. It might be printed to yours because your console's probably bigger than mine because my text is super blown up. So then you would also have min weight. Questions about this? Okay, this is all great, but one thing that I find myself constantly doing is I've isolated the thing that I'm interested in, but it's sometimes not that helpful to have things scrambled around like this, where you have 9.16 up here, and then 22 down here, and 154 in the middle. Instead, you would want to order this by like biggest to littlest or something like that. So we can also do that within our command. So we'll do surveys. Nope, that's not a pipe. Type it to filter. Do is.na of weight to remove weight from our data, or the NAs and weight from our data set. We'll do group by, and we'll give it the column sex and species ID. Another pipe. Summarize. We're calculating mean weight, which is the mean of the weight column. And then put a comma after that, and we'll do minimum weight, which is the minimum of the weight column. And then we'll do our pipe. And this time we want to arrange. I'm going to make this a little bigger for a second. We're going to arrange by our minimum weight, this new thing that we just created. So if I run this, what the arrange function did, tacked onto this, is take our minimum weight column and it's ordered it for us from smallest to biggest. If you wanted this in the other order, you can add another function in here called descending. So it's DESC. And then I put an open parenthesis before min weight. And then RStudio is being really helpful for me here. It put a red underscore squiggly line, kind of like you see in Google Docs or Microsoft Word when you spell something wrong. And it put an X because that's such a small squiggly line that I might not see it. And the reason why is because I have not closed off the parenthesis for this function. So I have min weight with descending, and that one's closed off, so that's a proper pair of parentheses, but there's not a closed parenthesis after a range. So RStudio is telling me that. If I close off my parenthesis, the squiggly and red X go away, and then when I run this, I see that my biggest weight is, my biggest minimum weight is now at the top, and those were printed instead. So it goes from 130 on down to 35, and at the bottom would be those 4s and 5s that we were seeing before. Questions about that?
What about ascending?
Ascending is default. So if you want ascending, you remove that descending function. And now it's ascending. So it's 4, 5, 6. Okay. One more useful thing is counting. So if we take survey, oh yes.
So what if you wanted to first like sort by min weight and then sort by min weight? Would you pipe it again to a range, to another range?
I don't know. Let's play and find out. I'm going to alter this arrange and do mean underscore weight, comma, min underscore weight, because that seems like it maybe would make sense to me. Yay, it worked. I didn't know that that was going to work. Yeah, so if you want to sort by multiple things, so what happened here is that I put mean weight first. So it's sorted by mean weight first. So I see that this is in ascending order, and those are all in numerical order. And then it's sorted by min weight. Let's do the opposite though, because we probably don't have very many mean weights that are exactly the same, so it doesn't really make sense to sort within those. So we'll sort by min weight first and then mean weight. Yeah, so then we see that we have 4, 5, or all the 4s here, and now these are ordered nicely as well, where it's the smallest, the biggest within the 4s. Other questions? Sorry, because I deleted some of my code, I'm gonna fix it so that it's not deleted anymore, so it's a good, captures all the things that we did. So we're arranging by 2 columns here, and then here we're, instead of ascending, we have it in descending order that the mean weight's gonna be printed to us. Okay. Now I want to count things. So if I take surveys and pipe it to count, this counted the number of rows that we have in our data set, because I didn't give it anything else, any other criteria to count on. So it counted the number of rows and that's it. But count pairs nicely with other arguments as well. So if I do surveys and pipe it to count, and then give it the argument sex, count knows that we want you to look at each of the levels that's in sex, so female, male, and NA, and to count the number of observations that we have in each of them. So we got back the 15,000 females, 17,000 males, and then the 1,700 that we couldn't capture data for them before they squirreled away. You can pair, so this is shorthand for what we've been doing this whole time, which is surveys piped to group by, and we're grouping by sex, and then piping that to summarize. Yeah. Summarize. And then making something called count and giving it the function in. So that does the same thing, but it's a lot more useful, or sometimes easier, and it saves your hands some work if you use this first notation with the count function.
Those two are equivalent.
Correct, yep. I should be commenting a lot of this, and I'm not, I'm sorry. I'll go back through and add comments before I save the final draft, if that's useful. Okay, yes, so those are equivalent. And even more better, even nicer about count, is that you can use the count function, give it your column that you want to count, and then you can also give it the sort argument and say that it's equal to true. So now we're sorting by, that's actually in descending order, which is not intuitive, but that's okay. Okay, and then count also will work like group by did, where you can do it on multiple things. So if we do count and give it sex and then species, so we're giving it 2 columns, we now see that it's split it out by both the sex and then the species name. Well, it's not the whole species name because it didn't combine it with genus. One more thing to show you with count. So we can, even though it has a sort argument, if you want to sort on more specific criteria, you can do surveys and pipe it to count. Again, do sex and species, sorry, that we're grouping by. And then this still plays nicely with a range. So you can pipe it to a range, give it species, and then also say that you want another column sorted, and in this case we want n to be descending. So we see that the count column is automatically named n, so we're sorting on that as well. So alphabetical, when you give something that's a character vector like this, it arranges species alphabetically, and then we're saying to do this one descending. So if we do that, we now see that the A's come first, and then we're descending with the count. So within the albigula, we have 675, 502, and 75. So we have 3 challenge questions here that if you are interested in doing them, you can now take the next hour to work on them, and we can come around and help, or you can ask questions. If you say, I'm sick of R for the day, you can abandon it and never look at it again. And it's up to you. Do you have any other questions before we, yes?
I think I remember running into this issue before of trying to get a 0 to come up in my counts. Like I wanted, see how there's like for it's just NA, but I want the value of male and female because I wanted to do calculations on the value of male and female for that. If that's a complicated answer, I don't need to get into it now. I'm just curious if there's some other like simple step that we can insert zeros into the values.
Drop levels. There's like an argument for it.
You can actually use replace. So if you want zeros, you can do replace NA, and it'll replace it with. There's several functions. I think replace underscore NA or something like that. Replace it with whatever you want. So we'll go through and fill NA with 0.
And it will know that. How does it know you're talking about the NA? Because you don't want to put. I don't want the 0 at the NA for.
You want to have like male bolineata
0.
n equals 0.
Right. Or
female bolineata.
maybe it's complete cases.
Or like I think it's drop.
It's dot drop by, and then you have to use that to get all.
There's another one that's a dplyr. It's a tidyverse function that actually goes through and will make sure that it fills all your levels with levels. I definitely use it.
Okay.
But yeah, it's pretty slick. I've definitely used it. It's nice for this exact thing where you're like, I want to keep all that info, but
It's in group by, in the group by function, there's an argument that's dot drop.
Yeah, dot drop. Yeah, that's right.
And I think, so you could do like sex, species, dot drop equals false.
So
And then,
I wonder if we can do that.
So the default is that it drops it, and it's saying don't drop it.
Yeah, it's saying
Yeah,
don't drop
I
it and fill it with an NA, and then you can replace the NAs on the next line. So it
So let's try this. I know.
I think it's add. I think it's actually dot add equals true, and that will add in levels that don't exist.
No, it's not drop. Why isn't it working? Is it giving you an error?
No, it's just there are no zeros showing up. It could be.
Oh, it'll replace it with an NA.
No, it's not doing that either. There should be some values in n that.
Okay, let's look at the documentation. So if I do a question mark and then I give the name of the function with or without its parentheses and run this, the help pane pops up with the documentation for the function. So I've pulled it up for group, and it says add is equal to false and dot drop something. So let's scroll down a little. When dot drop is equal to true, empty groups are dropped. Okay, so we have dot drop is equal to false, and then add. When add is equal to false, the default group underscore by will override existing groups. To add to the existing groups, do add equals true? I don't know what that means. Let's try it. That didn't work either.
I think it's a step that's not, I haven't done it at least in group I. I've done it with a separate function. And then, we'll
So
see.
you're trying to get all combinations of sex and species, right?
Yeah, so like,
That's exactly what it should do, so I have no idea.
so like for this one, which has neither male or female, I want male bilineata 0, female bilineata 0.
It's not gonna give you, so that one only has what level?
Yeah, this one I'm thinking of does what you just said.
Do you remember?
I'm looking complete.
So it'll do the
I think
NA.
the problem is that those combinations of data don't actually exist in the data at all. And so if there's like a,
Oh.
it's not that it's dropping, like, if you were, I think it'd be something like if you were calculating the mean and there were a bunch of them that just had NAs, and so you would just be left with that, it would drop ones where the result was NA, but you're looking for explicit zeros, which say there are no male Bailey or whatever.
But yeah, I can see you wanting that though if you're trying to plot. Like,
No, I agree, but I think it has to be done outside
Right.
of
No,
this
So
prior.
So complete is the
so
function.
why, so like dot
Can you
drop,
give it a group?
Oh, I have someone talking to me too
Oh.
in the chat. Not sure why or if me jumping in remotely is useful, but dot drop F worked for me and gave me
yeah.
F Audubani.
It always
N
works
equals
for
0.
me.
I think it's what Michael was saying, where it depends on your like the actual data that you have. So if you like, there's no males
Oh.
that are bilineata, so it's
Yeah.
not completing the cases in the group by. So
Is the
let's.
function complete?
Right.
Yeah.
Okay,
But you have to give it which
That's what I just
ones.
said. Yeah, you give it a group and then you give it what you're interested in. And then
so let's complete the sex and the species after our group by, and then tally and arrange. So if we do this, we now have.
you have to fill by.
Oh, I've done this too.
It's like the group, then the nesting of the group, and then what you want to fill by. So fill equals to 0 or any equals to 0. I think. You might have to look at that.
Let's look up complete.
Yeah.
Sorry, Ryan, I didn't mean to cut you off a second ago.
You're good.
Fill equals list.
Protein supply.
Also, like a thing that I've never thought of before.
Yeah.
This is fun. A named list for each variable supplies a single value to use instead of NA for missing combinations. So let's just do this for sex because I'm not going to do that for species. So fill is equal to,
0, I think, right? Or,
I think it might be F and M. Making it up as I go.
Yeah.
Nope, I'm wrong. So let's do fill equals 0. Do let's look at the examples. DF complete. Oh.
We have to give it both group. It's the same sort of group by option, maybe.
So the dot drop function also has changed recently. I don't know if that matters. It used to belong to whatever, like summarize, and now it belongs to group by.
Yeah.
So. So that might be.
Oh my goodness. Whoops. Now is when I would go on Stack
I don't know
Overflow.
what the difference between, because I've used both this complete function and then also dot drop, but then what would be the difference?
I'm not sure. I
Oh.
don't use the drop. That
Okay.
option.
Yeah, because I feel like they should do the same thing.
I think dropping is more along the lines that Michael was saying, with dropping levels
But no,
that
no,
don't exist or keeping them, but it's still not going to fill them with 0.
no, it's gonna fill them with an NA.
No, it won't. It
It
won't, because they don't exist. It won't create new combinations in a table that don't exist. So it will not make. So
Oh,
there, what you did just
It didn't work.
Wait, it looks like it did. You now have, or no, never mind.
We basically don't want any NAs in the sex column, right? We want all those to be male and female,
No,
and then
that's,
zero.
those are okay, because you don't know what some of them are. It's
Oh,
the-
got
You
it.
want it to be so, see the
Filling
Booleaniata, you want a male and a female entry for Booleaniata, and you want the counts to be 0.
Right.
So we want 3 for all of them like this one has,
Yeah.
but for
Yeah.
Booleaniata, it's going to become 0.
And complete should do that.
Should do that some point. Yeah. Let me load it stuff up.
And in this case, you wouldn't really want that because you have this NA, so you don't want to like imply that you know there's 0
Right,
males, but in
right.
another case, without.
Yeah,
NAs,
yeah. That's for sure a useful thing to be able to do.
Definitely done this. I just don't remember how.
Yeah, I'm looking at my code right now, because I've done it using drop, like to create levels that don't exist,
That's,
and to fill it with NA. I mean, it does it naturally. So. Oh, try it in whatever function. Maybe it does go into the function.
Okay. I don't know what you're
The
suggesting.
dot drop, like if you're trying to tally, what is the function that you're trying to use?
This,
After the group, the tally.
It's
Yeah.
complete.
So like you're trying to tally it by those groups, right?
yeah, so you see how this one has 3 observations for the Bailey. We want 3 for Booleaniata as well,
Right.
but because there's no males and no female observations, we want those to say 0.
So remove the complete rate real quick, and then put the dot drop into the tally, and then see if that works. Dot drop false into the tally, and then run that.
Nope.
Here in tally. Try count instead of tally.
oh, I got it. You have to ungroup before you pipe it in complete. Of course.
Because it's a double.
Ooh, okay, so
So you do exactly what we've been doing, just pipe it into complete after tally, and then just complete sex, comma, species.
sorry,
And
nope,
then
nope. Ungroup.
Then
I'm
you have
ready.
to go tally first. Sorry, you'd have to do tally before you ungroup.
Basically just move complete below tally and undo.
Yeah, and then that should work. Yeah. This is a common theme, which is after you create a grouping, that grouping stays with the tibble. So
Yay!
frame.
Yay!
There you go.
Yay! Okay, but now let's make it so that
Close enough. But yeah. I think you do fill equals 0 maybe.
Oh, the difference, so the
Yeah.
But it still won't.
we can do it. Okay.
Oh, you have to give it a list. You have to give it a name. So you have to say n equals 0.
It's so fill is equal to,
list n equals 0.
okay.
Yeah.
Okay, so let's break down what we just did. So first, we grouped by sex, species, and we said don't drop any levels from this. So even if the level, like if we observe a combination that exists within our data set, even if it doesn't end up having a calculated weight that would have been NA, don't drop it. So then next we tally, and that gives us the count. And then we have to ungroup by our 2 levels that we grouped by, because you cannot complete cases on something that's grouped. Because complete works on the full data set. And so this gives us back that the thing without the groupings pre-told on it.
Can you just
Applied
say
to it.
again what you said? You cannot do complete on
A grouped data frame.
Okay.
So we're telling it that we want to complete our cases. I'm going to save this, sorry, of sex. Our nesting is species because species happens after sex, question mark, why that works, don't understand it quite yet. And then we fill our column that we're filling is called N. So let's scroll up a little. So that starts with, or the column name is N, and we're saying 4 things that we do not have complete cases for that we're adding complete cases to, make it a 0 instead of defaulting to an NA. And then we do our arrange thing so that we kept getting the alphabetical thing first and then the highest number after that. Does anybody want to take a crack at explaining the nesting of species?
Oh, one's like the major grouping variable, and then it's things that are nested underneath that.
Oh, okay.
It's a little weird, but
I think I still got the same thing even without. You get the same thing if you don't wrap nesting around it for this one. You still get exactly how the nesting works. Or if you do sex, comma, species, you just don't need to wrap nesting around it. That still does it, I think. Yeah, so you still get the same number of rows.
Okay,
so I think that here's what this says: to find all unique combinations, including those not found in the data, supply each variable as a separate argument. Or to find only combinations that occur in the data. So basically only if you have that species, then you use nest. So you would nest your things. So potentially that's going to give you something different where if you did nest, sex, and species, it's only going to find what's in the data, versus sort of complete would be all combinations, even if they aren't in the data. If that makes sense.
Are you saying that the nesting is necessary?
Not,
in this case, I guess it depends what you're after, because it might not matter.
it does matter. It
Yeah.
does matter. So it's the same thing that we've been going back to over and over again, where if we say it's nesting, there is no male bilineata that we have observed anywhere in this data set. So it doesn't complete that case because we don't observe that. So it doesn't add in that data. But here, if we don't nest it, it gives you that thing. There's no male bilineata, but we get that result back anyway because we want all levels. Sorry, that was a bad one because it's not, you can't see it, but it's there.
Okay, so you're saying taking nesting out in this case works. So
they both work. They're just giving you different. So it's giving you the species that are only. It's sort of what species are in your data set. If you nest and it looks across those, if the species aren't there, it's not going to complete that case. If it's in nest, if it is nested, if it's not nested, if the species, it doesn't matter. It'll fill across all the species you have, whether you found whether it's data recorded or not.
it's not nested.
Right.
Yeah. And I think the reason you would want to do this is because complete will get rid of, okay, yeah. There's an example that they go through in the documentation of how you can like combine the two.
Yeah.
You want certain things that don't exist, certain things always do exist. But
Like-
this I think also illustrates a common thing, which is if you do group by, it retains that grouping. Like if you don't see it, but that table, everything you do with it has this grouping attached to it. So if you're not going to be using it anymore, like it's just safe to ungroup, and things tend to behave more normally. Whereas if you retain the grouping, like you saw, we were like, why is this not working? And that happens a lot, sort of accidentally.
Especially if you write this object to your environment, like if you say, this is surveys 2, you kept your group by. If you do something to it again, you're not going to know that it still has this grouping. Well, I mean, you can check, but
Yeah.
It's not super obvious. So it is, yeah, that is something, that's a really good point.
So I think, oh, go ahead.
No, I just said cool.
Okay. Do you guys want one more explanation to determine like when you would use these, or did we hit that nail on the head and it's done? All right, no one's saying one more explanation, so we're not going to go over that again. Other questions? Cool. If you have specific questions, we can come around and answer them, or you can ask your row partner, because all of you are smart humans. And thanks for coming.
Thanks.